Hello, Devox Belgium. You're here for the very last talk. Big applause to you. Woo! After 3, or maybe for some of you, 5 amazing days, you made it to the end. So, congratulations. And I'm actually thrilled to see with how many people you have gathered here. So, thank you so much for joining this talk. At the last end of this conference, we're going to talk about how to create your ultimate learning environment. Because it's cool to attend a conference, of course, but what we really want to do is take all that knowledge and really apply it right in our day-to-day job. And we don't want to do it only one time a year. We want to learn throughout the entire year. So, can I see some raise of hands who did see the talk Wired 1.0, Learning New Programming Languages? Okay, thank you, quite a few. So this talk is about the same topic, which is about neurology, linguistics, but especially integrated with IT and to make it possible to learn optimally. The talk is completely different, but it's about the same topics, right? So if you haven't seen Wired 1.0 in the last slides, so hold on a bit, you will find a QR code to Devox last year where I did that talk, and you can revisit it. All right, so a little bit about myself. I graduated in 2015 as a speech and language therapist, and I actually never did something with it. So I have a degree, it's amazing. I did a lot of study on it, but afterwards I immediately switched to IT, and I currently work for Open Value as a Java and Kotlin developer, which I really enjoy. Yeah, Ooh, Open Value. Whoop. Yeah, I actually really enjoy combining the two fields. I think the brain is super interesting, but it's also really very applicable because we are in this ever-changing world. We have seen it. AI is all around us, and what is next for the future, nobody knows, but there will definitely come something along the way. So let's try to make learning as much as a positive experience as possible and as efficiently as possible. So let's dive in. Maybe you have seen a model that looks a little bit like this. There are multiple going around, but all of them are kind of similar to this. It's the information processing model, and it's actually a model that tells it how we are processing information. Because when we are going through this world, we're experiencing things through our senses, right? We see things, we hear things, we feel things, etc., etc. Now, when we put our attention to that, things end up in our short-term memory. In Wired 1, I really dove into the different memory storage, so I skipped that for a bit, but just take it as a fact that if you put your attention to it, it ends up in the short-term memory. However, if we really want to do something with that data, if we want to analyze it, if we want to problem solve, we want to have it in our working memory. Because in our working memory, that's actually where the magic happens and where you do the thinking. It's like the process engine. However, we have this guard, this some sort of filter that kind of determines which information gets prioritized to end up in the working memory. And that guard can sometimes be a little bit annoying from time to time. The guards are called emotions. Yeah. Emotions are actually one of the biggest determinators if information will end up in the working memory. And that is because even though we feel as if we are very highly sophisticated animals, we actually are still quite primal in the core, right? The hunters and gatherers are still within us. And actually, our brain is primarily focused on survival. So whenever something is coming up that has to do with survival, it will prioritize that data. So if you hear a fire alarm or you see a big spider, which you are terrified of, or anything else that's maybe a little bit more dangerous, your brain will clear out the working memory with the data that's currently holding, and it will take up all the information needed in order to get you out of that situation. Now, luckily for us, we're most of the time not in life-threatening situations. So the next filter step, so to say, is that it is prioritizing data that is generating emotions. So you probably know a situation where you wanted to focus on something, but you were just too overwhelmed with certain emotions. And those emotions could be highly positive or very negative. Anger, sadness, and those emotions were preventing you from really focusing on the task at hand. Um, and it makes sense, right? But it's something to take into account that when you want to have a new learning, that you need to be in the right state of mind. Otherwise, firstly, it will require a lot of focus or a lot of energy to really focus on the new learning. But apart from that, it's a given that most information is lost within the first 18 to 24 hours. So we actually want to retain the information, right? We really want to save it and learn from it on the long term. And with all those emotions going around, the chances are very low that you will actually do so. The second thing that has to do with generating emotions is the emotion that is generating based on a previous experience. So let's say you are learning about a certain topic. Maybe you were in a refinement on your job and this topic just went over your head. You couldn't quite grasp the material. Maybe people were going too quick, and throughout that meeting, you felt those negative emotions boiling up, right? Maybe first you got annoyed, but by the end of the meeting, you actually got disappointed maybe in yourself. You thought like, oh man, I never am going to be able to grasp this. And throughout, all these negative emotions were attached to that specific topic. Now, that sounds innocent, but your brain is remembering that, and that is now connected to each other. So the next time that topic comes up, your brain will already try to distract you from it. Maybe focus on something else. Maybe don't participate in a meeting. Maybe let your colleague pick it up. Now, luckily for us, we're all adults and we have something like free will and stuff, and we can actually overcome this and make a deliberate decision to actually do focus on it and try it again. Give it a second chance, so to say. However, if we're not aware of this filter, of this guard, it's very easy for us to just go with what our brain is telling us, right? To not give it a second chance, to just focus on something else that is more easy for us. All right, but with all that out of the way, if we don't have all these emotions going around, we don't have negative experience, then our working memory is actually clearing up to focus on new information. So before I really dive in further, are we feeling calm and mindful at the moment? Yes? Can I see some thumbs? A little bit more energy, people. Yes? Woo! All right, awesome. Cool. It's the last talk. All right, cool. So we're in the working memory, new information is coming in, you're fully engaged, and now we actually want to make it through those first 24 hours, because that's what we're here for, right? To also remember it in a week from now. So we want to encode it. And the two biggest indicators that you need to focus on before you really do your learning is to ask yourself two simple questions. And those are about sense and meaning. The first question is about sense, and that is the question, do I understand it? And that question can only be answered based on your past experiences. Do you have enough foundation to build this knowledge upon? If you have not, maybe you need to take a step back or several steps back in order to make first a foundation where you can build upon and attach the new learning towards. I think we all know this, right? And even if we don't notice it, we notice it in our body, right? When you're in a talk, just like I mentioned before, if you're not grasping it, you feel those negative emotions boiling up, like, oh, I don't get it. So this question is it's important to ask ourselves, especially to go beyond that, right? And to really think like, okay, how can I make sure that I do get it and how can I tone it down? But the second question is a little bit less likely to ask yourself, or at least I notice that a lot of people are not asking themselves this question. And this question is, why do I need to know this? Because our brain is prioritizing data that it needs in the here and now or in the nearby future. And that's a good thing because with all this information going around us, we don't want to have every information piling up because you can imagine how what that does for the retrieval later on. It will be harder, right, if you have so much going around. So whenever you participate in a talk or you want to do a new learning, ask yourself, why do I need to know this? Of course, a talk can be inspiring, and sometimes that's enough reason, right? If you are motivated to work in this IT field because it's so cool and there's so much opportunity, then that is sometimes enough. But it doesn't immediately say that you will remember the details of that talk a week later. If you do want to remember the details, you need to make it relevant to yourself. How can you apply it in a day from now? Or how can you apply it right now? All right, so hopefully we have answered those two questions. We have enough relevance and we have enough understanding to take on the new learning. Now we want to retrieve the information. Well, good to know is that whenever we are storing information, we do that based on similarities, which makes sense, right? Because as with the sense indicator, we are looking towards past experience in order to build upon. So we're always searching for similarities to something we already know. However, if you want to retrieve it later on, you don't want to do that by similarities because you get confused and you might retain the wrong information. So you actually want to do that based on differences. So a key element of learning is always to try to focus on the differences first. Now, to take that for an example, in Java, we have inheritance and polymorphism, right? They're both concepts that are about reusing. But if we are purely focusing on one term at a time, it might very well be that in a week from now, you don't really know what is what because they were both about reusing, right? So whenever you're going to learn this, try to see what makes it unique, what makes it stand out. Now, all right, retrieval. Where does it depend on? Just like with the encoding and the indicators that I just gave you, we also have indicators for retrieval. Retrieval depends on the adequacy of the queue. Whenever new information, new data is coming in your working memory, you can see it as if those were cues. And with those cues, you're going to your long-term memory storage and you're basically knocking on doors. Does anyone have relevant information to this cue? Do you know something about this? And with all this information that you're gathering, you're going back to your working memory, and that's where you do the thinking, right? But if you can imagine, if the cue is already vague or wrong or inadequate, of course, whatever you're retrieving is inadequate as well. The second thing is moods and beliefs, because I cannot stress enough the impact of emotions towards your learnings. So whenever you want to retrieve information, maybe you're on a job assignment and you want to think of a solution for something, of course, you're not going to think of that one technique that you very much hate, because that's not something your brain will offer to you because you hate it. So moods and beliefs are very important and very deterministic in terms of what you're retrieving later on. Then the context of retrieval. Who has heard about the given that whenever you listen to a certain music during studies, let's say Mozart, I'm just saying something, and you listen to Mozart later on, that you then can recall the information easier, right? Okay, a lot of hands, I see some nodding. Yeah, we know that. But in IT, it is also the case with, for example, your code project that you're working on with your team. If you make certain clean code agreements within the team, and you know, and you hold each other against it in PRs, right? You really hold yourself accountable, but also your colleagues accountable. Then whenever you're opening the code, as a context, you already have those principles in your head, and you will automatically apply those principles to that code base. And it can even be that if you work in multiple teams, that you have multiple agreements with different teams, but whenever you open that project, you kind of automatically get stimulated to go in that those agreements category. And the last indicator, which I think is the most important indicator, is the system of storage. Now, your long-term memory is not in one place in your mind. The long-term memory is kind of all over. You have bits and pieces in your visual area, you have bits and pieces in your auditory area, in your linguistic area, you have it all around. And this system of storage, so wherever you are storing that information, is a learned skill. And we can train ourselves to get a highly organized system of storage, which is great because the retrieval depends on it. Important to understand with this is that the rate of learning is independent of the rate of retrieval. Those are two separate skills. If you are a very quick learner, if you just get it right away, that doesn't necessarily mean that you're a quick retriever, that if somebody asks you for a certain solution, that you are also able to retrieve that information and explain them about it. And vice versa, the same way. So while I was on this conference and with the last year in mind, I have been thinking about the implications of AI towards the rate of learning and the rate of retrieval. Now, as it goes with a lot of scientific research, is that it takes years often for scientific research to get published. Maybe you did in university, you did your end studies, and that already took a long time, and that wasn't even like a fully published research study. So you can imagine. And AI is so rapidly evolving that we don't have a lot of scientific research at this given time on the implications of learning. So as a fun experiment or a fun fact, I thought it would be cool to share my personal hypothesis on how I think that AI will influence our rate of learning and our rate of retrieval. And maybe in a few years we can look back and we can see if this hypothesis has been proven by research, yes or no. So I believe that the use of AI tools will accelerate our rate of learning. And that is because we have now AI at the tip of our fingers. It is super quick, it's always accessible, and it's personalized. You can tone it up and you can tone it down. You can even say like, I am a reader that likes to do assignments and practices and examples. I'm a reader that likes to hear stuff. I'm a reader, or I'm a learner that likes to read. You can just pick and choose, and it's always there. So it's way easier to get it because it's personalized and always accessible. However, I do also believe that it will weaken the rate of retrieval. And that is because whenever we want to retrieve information, we kind of want to train our neural pathways. Every time we retrieve certain information from our long-term memory, we are enforcing that pathway. We're strengthening that pathway, making it even more easier for the next time to retrieve that information. However, with AI at our fingertips, we don't really need that anymore, or at least not that often, right? We have AI right there in our code editor, and we have it all around us. Now, is this a bad thing? I'm not sure. It does we have all the AI tools, which are great. So at the moment we have it, I don't think it's a very bad thing because we did learn the information. Actually, it's even easier to learn the information. So you can judge whatever is given to you. And I think that's the most important thing, the critical thinking, the ability to judge what the AI is giving you. However, it is worthy to mention that we do implement a certain risk. if Elon Musk takes down all satellites, we are kind of screwed in a few years because we do get more dependent on our tools, right? And on the internet and AI to be around us, especially for the generations to come, I believe. So let's see in a few years if this has been proven right or wrong. Maybe I get surprised. All right, so the system of storage, that's what we're actually talking about. So to organize your system of storage, so your long-term memory, right? We want to make it as organized as possible. And we can do that via two things, so to say. Firstly, whenever you are learning, you want to focus on the critical attributes. We already talked about this a bit, right? We already said that you need to focus on the differences and what makes it unique. That's exactly what this is about. Now, the second thing is chunking. And for the people that did see Wired 1, they might have heard about the term chunks because it's explained there as well. And chunks are basically, it's a blob of information. And the more familiar you are with a certain type of information, the bigger the blob gets. So you want to be able to organize, to chunk the information inside your brain in such a way that you can retrieve it very easy and you have just this whole pile of information with grabbing one chunk. Now, how do you do that? Well, good to know if you want to chunk is that you can do it in two ways. Firstly, pattern chunking. And this is basically what you did when you were a teenager and you wanted to remember the lyrics of Bon Jovi or Nickelback or any other things that were the things that were going around in my youth, at least. So the step-by-step procedure. And in IT, we do it as well with syntaxes, right? For most of us, probably the for loop is just one big chunk. Whenever we think of a for loop, you can kind of dream this. But when you just started out, this for loop was definitely not one chunk, and it started all with splitting it up in several parts, right? Now, this is fun, and we do apply it from time to time, right? Syntax is still a thing. However, the thing that we use most is categorical chunking. And categorical chunking is basically how you define a category within a certain topic. So when I ask people, can you maybe categorically chunk for me databases? I get a lot of times, yeah, sure, I can do that. So you have databases, relational, non-relational, maybe document, key value types, etc., etc., etc. And that's great. That's a way of categorical chunking. But what I would like to challenge you with is to take it one step higher. You want to have a blueprint with learning that you can apply to every new learning task at hand. And database structures in that way is not something you can also apply to protocols or anything. So these are the things that I use as a blueprint. Whenever I'm learning, I apply certain chapters to my learning. And those chapters are advantages, disadvantages, differences, similarities, the structure and the functions, the hierarchical level. So that's actually where those database structures came into place, right? And just arrays of critical attributes. Now, this can actually be used as a blueprint to everything. And because you do this, and if you do this all the time, it's easier to retrieve the information because you always know where to find it. Now, does chunking really make sense? Or is this just something I'm telling you? Well, luckily, we do have research on this specific topic. And they took a group of developers, beginners, intermediates, seniors, and they were asked to look at a piece of code for 2 minutes. Now, after 2 minutes, it was taken away, and they were asked, can you fabricate the piece of code again? Try to write as much down as you still remember. And the results were significant. It was very easy to determine who were the seniors, the intermediates, and the juniors, because it was very clear from the results. However, when they then scrambled the codes, so they completely made it like bullshit code, just random words and letters and etc. etc. And they repeated the exercise, the results were far less significant, not as significant at all. They were far more closely together. And that is because seniors don't necessarily have better memory skills. It's not that they can recall information better or more easily, but it's because they chunk in a better way. They have been chunking for a longer time, and they are able, whenever they see a piece of code, to make it into several chunks instead of all separate characters and words. If you want to learn how to chunk for yourself, you can participate in a code reading club. This is a cool exercise to do with colleagues, for example. It will give you insights in how you are chunking and how other people are chunking and how you can like benefit from that, right? Because we can all learn from each other. So the top QR code is actually a GitHub page where you can find all the material that you need in order to organize for yourself. And the second QR code is from Marit van Dijk. She actually did a talk on reading codes during DevOps 2024. So you can also already see that on YouTube. All right. It's time to talk about time and for me to take a sip of this water because I'm very thirsty. When we are going throughout our day, we are going through numerous cycles. So our body is having cycles like hormonal cycles, blood pressure, heart rate, etc., etc., etc. And because of those cycles, we get in natural highs and natural lows when we talk focus-wise or energy-wise. Now, that's great. But that also brings us to the dark hole of learning. And the dark hole of learning is the lowest point of focus, which is just past the middle of the day. I think we're at the close end of the morning peak, and we're diving, after this talk, we're diving into our dark hole of learning, which is brilliant because we're done with that, folks, at that time. So you can fully give into that dark hole. Now, it's good to understand this because because this is just going on, we can plan for it, right? We can do learnings in the beginning of the day, and if you don't have time at the beginning of the day, rather than do it just after lunch, try to do it in the late afternoon. Now, something else time-related that we can plan for is the primary recency effect. And the primary recency effect basically tells you that you have a prime time 1, followed by a downtime, followed by a prime time 2. Now, what this basically means is that whenever you have new learnings, and my lower arm is now the working memory, new information is coming in, right? The working memory has limited capacity, so the working memory is slowly filling up. At a certain moment, you will feel the change in your body and in your focus. You will probably get tired, maybe your focus is lacking, you want to grab your phone, get distracted. That is probably a sign of your body telling you, hey, you're close to the end of prime time 1 and you need some downtime. You're loading up. Now, that's fine as long as you don't give in to that call of destruction and the endless scrolling on X. Because the fact that your brain is fatigued is very dangerous for you to grab your phone at that given time, because it is already hard for everyone to go out of a scrolling loop. However, at that time, your brain is also fatigued and it's even more difficult to get out of it. So how do we want to spend the downtime then? Well, downtime can be spent in several ways, but whatever you want to do, you don't want to take in new information, right? Your body gave you a sign, you're full. You need first to digest the information that's in here. So you can do, I think, mostly 2 things, and one of them is work with the information that's in the working memory. So practice with it, maybe reflect on it, write down some questions and answers for yourself. Or you can give your body a break by walking around, because it's a given that after 20 minutes of sitting down, the blood flow in your body is decreasing. Most blood is staying in the lower part of your body, making it so that your brain gets less oxygen, making you fatigue as well. So maybe spend a downtime on walking around, maybe grabbing a glass of water, because your brain also loves that. Um, and after that, if you have some time to spend in the downtime, it will clear up. What it basically does in that downtime, it's throwing away all the information that wasn't relevant, and it's chunking the information that you have gathered here. So during the downtime, you are getting new information, or you're getting new spots, new capacity, and you can spend your prime time 2 filling that up again. Now, research has shown that the downtime does increase the longer you push yourself to extend the prime time 1. So if you have a learning episode of 60 minutes, instead of having it consecutive, so one big prime time 1, then a downtime, then a prime time 2, rather split it up in 3 cycles of 20 minutes. Now, how can we apply this knowledge in our day-to-day job? Because it's lovely if you get the dedicated time to learn, but a lot of the times we are just coding, right? So how you can use this information is, whenever you're picking up a new task, instead of immediately diving into the task, take 20 minutes. I am pretty sure that most of us have 20 minutes to spare. So whenever you pick up this new task, first look at the code where this solution will live in. But don't focus on the solution, just focus on the code at hand. Try to read through the code and ask yourself the question, okay, what stands out to me firstly? Secondly, how are things related? Do I understand, or don't I understand certain concepts or elements? And try to really investigate on the code where it will live in. Then after that time, you have 2 minutes where you can do some squats, get a drink, walk around, whatever. And then the last 8 minutes, you will try to research for the things that you felt unsure about, or that you felt could be optimized maybe. And only after those 20 minutes, you're only then focusing on the solution for the task at hand. And that will give you so much more embedded knowledge about what can be improved, how this code can be better maintainable, but it also gave you an opportunity to learn. Now, with the preparation of this talk, which I did in the beginning of the first half of this year, I actually made an example on a dedicated learning interval of 60 minutes, and how you can divide it in the prime time 1, downtime, and prime time 2, and then in 3 blocks. And this was great, and I highly recommend for anyone to do it yourself. But I actually thought, why not try to see how we can integrate AI in the learning episodes, and let AI help us optimally, so that we can actually accelerate in that learning, as what the hypothesis just taught us. So firstly, how can AI help us plan? Well, let me see. So we go to ChatGPT, right? Does anyone have a topic that I can plan for? What is a topic that we want to learn about? Anyone? Quantum computing. Awesome. Okay. Hello, assistant. Always be nice, right? Hello, assistant. Can you make planning for a learning episode? Topic is quantum computing. Learning block is 60 minutes. Divided in 3 blocks of 20 minutes. Every block having a prime time 1, downtime, and a prime time 2. Let's see how that goes. Okay, cool. So, oh, That's sad. Let me see. How can I get out of this? Swap it. Nah. No. Now I really have got car. No. Okay, then I'm just going to end the show. Let's see. Right? Is this big? Yeah, right? Yeah, big enough. Okay. So I just I just wrote down this question for ChatGPT to help me plan with my learning in the fall, and it now gave me 3 blocks. You can see block 1, block 2, block 3. And they said, okay, in the first prime time for 7 minutes, you're going to investigate in quantum computing. And then, so you're just going to research on these topics. Then you have some time for interactive reflection. So it's actually encouraging you to work together with someone else and asking to each other, like, what did you find interesting or challenging? And encourage each other to to write down 2 takeaways. And then in the second prime time, you're actually going to look for real world applications, apparently, which I love because with this prime time too, you're actually adding meaning, right? You're adding relevance. Like, okay, quantum computing is great, but is it really relevant to me? Do I really need to know it? And with investigating how you can apply it in the real time worlds, you are making it relevant to you, making the chances way higher that you will actually remember the information of prime time 1. Now, I will not go over this whole entire thing, but what I love about the fact that you can plan ahead with ChatGPT is that a lot of times ChatGPT comes up with a lot of challenging questions that I can ask myself that will trigger myself to think of this new knowledge in a different way. And it's also offering sometimes creative solutions like, okay, write or draw now down a model of this information that you just learned. So it can help you think out of the box, so to say. All right. The second thing I wanted to talk about is to summarize it. So we just talked about quantum computing, right? So we are going to see, okay, there's this big article on quantum computing from IBM. Awesome. I have this tool, Notebooks LM. I think Stefan also talked about it shortly in the keynote. And it's a place where you can add certain sources. So, for example, I now have this URL from IBM, which I'm going to add here. It's now loading up. And I actually want to also to have like a video. That would be great. Hype versus reality, amazing. Let's also like just put that into here. So I'm adding here also a YouTube thing. And then while it's computing, yeah. So now like I already get a summary, which is in my native language because Google is doing that. So just believe me that there's a summary. And the cool thing is actually that Notebook LM is offering you a way to make an audio, a podcast of the sources that you entered, which can be like tons, right? You can add here like 20 sources, which can be videos, but also web pages, and they are just generating it into a podcast. So this will take a few minutes, so we're not waiting for that, but I'm just generating it on the back, and we can see in a bit how that goes. So yeah, so it can summarize, right? It can vocalize. We will see that in a bit. And you can query it because now that I made both of those and I added those sources, I'm actually able to query upon this knowledge with this search content. And I actually heard of one of the other talks that you can also really nicely use Claude, but I need to be fair, I haven't used it yet. So I was just very hyped when I heard about it. So definitely check it out. I will too. So that's, I think, a little bit the same as with the Notebook LM, but I don't know yet which does a better job. So yeah, you can query on your information, you can focalize it, summarize it, you can visualize it. Now, for anyone who's seen Wired 1, you might remember that your brain loves multiple senses. So whenever you are learning, it loves getting the input via different ways. So that's just like when you learn a kid what a dolphin is. it's amazing to talk about a dolphin, but it's even better if you can show the dolphin, and if they can hear the dolphin and interact with it, right? So visualization is a big thing, and that we don't really overgrow that when we're adults. So that sticks around with us. But visualization is often a challenge, right? Even though it's really positive to try to make the visualization yourself because you're creating something at that moment, and that will also help you embed the knowledge, you can also help ask AI to help you in this. So a site I use is Napkin, which is pretty cool. So Napkin, you can enter your summary in of your learning, and whenever, like I have here a text that is about how the process flow goes for registering and getting a certificate for DevOps, which is just a basic text, right? Now, if I press on that lightning bolts, I get here all kinds of different styles of images, and I can just pick whatever I like best. Now, as you've seen in the example below, which I already prepared for a little bit, I picked this process flow, which is great. And it's actually like it just got it out of that text. I didn't need to really add it. It was just created for me because it understands the text, and I can pick which diagram works best for me. Same thing goes with mind maps. Like you have all kinds of stuff, and you just saw right when it was generating that you have tons of options. This can be used for hierarchical things. And what I love about this is the fact that even like it's visualized, right? But even with icons. And again, the brain really likes visualization also in terms of icons, connecting a real image to something that you learned. So this can really help improving your knowledge. And lastly, differentiate. So what I also really like is that with ChatGPT, you can ask like, "Hey assistant, can you make a table on Quarkus and Spring Boot and ask and tell me the differences between both?" Now it will now make an markdown table for me, and I really like it because you can of course search for this for yourself, but as I mentioned, it's really important when you start your learning to first focus on the differences because that will really help you retain the information later on. So tools like this can really help in toning it down, what is different, what is unique about this new learning. Now let's see how this is going less quickly as I hoped, to be honest. One small QR code to one of the talks on Wednesday. The whiz boy Nazardine, who talked in the keynote about creating this nuclear fuser, also did a talk, and it's really cool. Like the few slides I'm just showing you guys, and the tools that that I am using, he's taking that to the next extent. He's even a bit younger than me, I believe, and he's applying AI to anything. So if you really like the AI tools and how you can integrate it with your day-to-day life, it might be fun to watch his talk. Okay, so unfortunately, this is not going quickly enough. So I'm just going to show you something I prepared for already previously. So I had here a Quarkus example. I'm taking it, and well, too bad. If this, then you have to believe me because I also saved something.
Excellent. Ready to dive in. Today we're tackling something pretty huge: artificial intelligence in education. Not just the techie stuff, but how students like you are actually using it, what they think about it, all that.
Yeah, it's one thing to talk about AI in theory, but seeing it play out in the real world, especially with students, that's where it gets really interesting.
Totally. And we've got some great material.
Okay, so you don't have to listen live with me to this entire podcast, but basically what it did is I had this research article from AI, and I had another one from another scientific research article, and I placed them both in Notebook LM, and they made a podcast out of it. And it's amazing because before that podcast didn't exist, the people don't exist. But it's a great way if you don't want to read through certain articles, through certain blogs, you just like throw your sources in there and generate a podcast for yourself. All right, so let's open up my presentation again. So last year, I have been asked a lot how I feel about artificial intelligence. Should we use it? Is AI the future, or should we also stay away from it a bit, at least in terms of knowledge of learning, and how dumb are we getting? Well, I think it has everything to do with critical thinking, right? Are we able, throughout time, throughout the use of artificial intelligence, to remain our critical thinking? Well, critical thinking, just to tone it down a little bit, is all about asking yourself higher order thinking questions. That's basically what critical thinking is. Can you ask yourself continuously critical questions on whatever you are coding, whatever you are reviewing, whatever you are judging from the AI tool? Now, those are some examples of questions you can ask yourself during your coding, and there are of course tons and hundreds and thousands of extra questions. But what is important, I think, to understand is that critical thinking in itself is a skill. And a skill can be trained, right? It's something that over time, the more often you do it, the more natural it becomes and the more automated that question will pop up. Whereas artificial intelligence is a tool. And I think it's the most important thing that we try to understand, that we need to keep training the skill of critical thinking, which is maybe less triggered, but even more important. And that is actually also what I said with the rate of learning and the rate of retrieval. That is actually where it makes a difference in order if we want to use artificial intelligence, and if I would say, do we want to use yes or no? So I think, yes, we want to use it, but we want to learn how we can apply critical thinking to the skill. And we need to train ourselves for that. And I think the biggest challenge with that is holding each other accountable. Holding, like, the peer review sessions will become way more important even. And they were already very important. But reviewing, asking yourself the questions, not only like having, how do you say that, pair programming, and just looking over each other's shoulder, but really, if you're not in the steering wheel of the pair programming session, really keep asking higher order thinking questions. And you can even, if you find it tough, if you don't know what to ask, because especially like those questions come in time, right? It is a skill, so it comes easier over time. So if you're a junior, it's way harder to come up with those questions, especially if everything is generated for you. So you can even like hold questions next to it. You can even ask AI to come up with higher order thinking questions that you can ask yourself about that code. But it is a fun challenge to see. And I think the responsibilities lies with us. So with that being said, those are the sources that I mainly used for this talk. And I really want to thank you for your attention. And I hope you have a great afternoon and you really enjoyed DevOps. Thank you.
All systems are nominal. Initialize Genesis sequence.